Alright, for this video, we're basically going to apply what we just learned about zeros and roots of a function. Nowhere in the directions does it say find the zeros, but you really are. Now we have an equation, and it's saying we want to solve each equation by factoring. The main thing when doing this is you always want to have the equation set equal to 0. And then we'll basically find the zeros of the function. So for number 11, all I have to do is I need to get rid of this 4. So in order to get it to equal 0, I'm going to subtract 4. So I subtract 4 here, so I have it set equal to 0, and then I subtract 4 from the 116, and that's going to give me 112. So on the left side, I have that quadratic trinomial of 7p squared plus 56p, and then plus 112. And then we're really going to basically factor it. I have a quadratic trinomial, so we're kind of finding the zeros, or the x-intercepts for this equation. Now remember, when factoring, you always want to look for the GCF, and there actually is a greatest common factor. 7 goes into 56, and 7 also goes into 112. Goes into it 16 times. So by pulling out that GCF, it's going to make our work a whole lot easier. We're going to deal with smaller numbers inside the parentheses. So I'm going to pull out the 7, then put the parentheses. It's still set equal to 0, and then let's put the plus in the plus. Okay, and then let's see here, 7 times p squared gives us that, 7p squared. Let's see, 7 goes into 56p 8 times. I'm going to have 8p, so plus 8p. And then, as I mentioned before, 7, that goes into 112 16 times. So 7 times 16 is 112, so I have plus 16. Alright, now your whole goal is you want to basically factor out this quadratic into 2 binomials, into 2 linear factors, and this is going to work where I'm still going to have this 7 on the outside, and this is going to factor to, and I'm going to have p plus for each, and then I just ask myself, alright, what are 2 factors of 16 that add up to 8? Well, it's 4 and 4. So 4 times 4 is 16, and 4 plus 4 is 8. And then when I solve this, this really doesn't mean anything, because that 7 can never equal 0. I would only take each of these, the p plus 4s, and set them equal to 0. You get the same answer for each. This actually is called a double root, and we wind up just getting one answer for this, because it's a double root. We get p to equal negative 4. Alright, let's move over to number 12. The good thing about number 12, it's already set equal to 0. So I don't have to rearrange anything. So if I solve for this, I know that I'm finding the zeros. Okay, again, look for the GCF. I have 12, 48, and 45. The biggest number that goes into them is 3. And they all have x's, and that smallest one's x. So the GCF for number 12 is 3x. I'm going to put my parentheses. Okay, I'm going to line up the minus, line up the plus. Right, and let's see here, 3 goes into 12, 4 times? I'm going to have 4x squared. Let's see here, 3x goes into 48x squared, I believe it's 16x? So that becomes minus 16x. And this 3x goes into 45x, so it's at 15 times? So that's plus 15. Alright, and then again, I'm left with this quadratic. I can try factoring this into 2 binomials. I'm still going to bring down the 3x. And then I'm going to factor this into 2 binomials. Again, really, you do this by trial and error. Since this is 4x squared, I can have 1x and 4x here, or 2x and 2x. I think what winds up working is if I have 2x and 2x in each of these. So I'll put 2x and 2x. And then the other thing, since this is a positive and the first one's a negative, that means both of these are going to be negatives here. So I'm going to put minus and minus. And then the numbers here have to be factors of 15. And what winds up working is just 5 and 3. So I'm going to put 5 and I'm going to put 3. And again, if you FOILed this whole thing out, it would equal this quadratic trinomial. And then what's going to wind up happening, I actually have 3 factors. I'm going to split this up. I have 3x, 2x minus 5, and 2x minus 3. set all of them equal to 0. Now if I set 3x equal to 0, well that's just going to be 0, because 3 times 0 is 0. If I set 2x minus 5 equal to 0, well that would be a two-step equation. You would add 5 to 0 and then divide by 2. So this x would be 5 halves. And then for the last one, set 2x minus 3 equal to 0. That's going to be two steps. Add 3 and then divide by 2. So x is going to equal 3 halves. So this is one where we ended up with 3 answers, or 3 zeros, or 3 roots.